Hello friends, today we will start our discussion about types of databases. On the basis of management of database and the architecture of database, the databases can be categorized as: first, on the basis of architecture, the databases can be categorized into centralized databases and distributed databases. And on the basis of management, the databases can be categorized into hierarchical DBMS, network DBMS and relational DBMS. Let us start with centralized DBMS. In these types of database is physically at one location in mainframe or servers. Users at remote locations access the data by using an internet connection, using the application programs provided to access the data. This is the traditional approach to store the data in large enterprises. For example, banks tend to use centralized databases. What we mean is a single database is maintained at one location. It is managed by a database administrator usually. We will define database administrator shortly. The access to the database via a communications network like LAN, WAN, terminals providing distributed access. So, look at the figure showing the centralized database maintained by the banks. There are number of ATMs serving the customers. Customers are sending the requests for various transactions to the bank database server placed at one location, and this server is serving the requests through various communication channels like telecom lines, LAN, direct link, etc. Now, what are the advantages of centralized databases? First, increased reliability and availability. As data resides at single place, so all the users receive same type of data. This increases its reliability and availability. Next advantage is lower communication costs, means different users use internet links to access the data stored at one place. This storing of data at one place reduces overall communication costs of data accessing. Next advantage is faster response. Since each request is received at one place, thus it fastens the response time. Now, we come to disadvantages of centralized databases. It includes software cost and complexity, means this management of database is complex in nature, since different communication lines has to be set up for accessing the data of database, and also the cost of software used is high. Another disadvantage is processing overheads, means because each request is handled by single server, thus the processing of request overheads is there. Next disadvantage is data integrity. It is hard to maintain the data integrity in this type of databases, as multiple users access the data. Thus, when multiple users modify the same data, and thus it leads to non-integrity of data. Let us proceed to the concept of distributed database management system. A single logical database that is spread physically across computers at multiple locations that are connected by data communication link is known as distributed databases. The data is stored in storage devices that are located at different physical locations. These computers are not attached to a common CPU, but are controlled by a centralized DBMS. Each side has its own database and operating system. To keep a distributed database up to date, it uses the replication and duplication processes. The replication process identifies the changes in the distributed database and applies those changes to make sure that all the distributed databases looks the same. Depending upon the number of distributed databases, this process could become very complex and time consuming. The duplication process identifies one database as a master database and duplicates that database. This process is not complicated as the replication process, but makes sure that all the distributed databases have the same data. Now, we move to the features of the distributed databases. First is most processing is local. Another is need for local ownership of data, and data sharing is required. Now, look at the figure depicting distributed databases. So, what are the advantages of distributed databases? It minimizes communications since all the data in these databases are present locally to the users. So, it minimizes the communication between the database and users. Next advantage is costs. The cost of setting up these databases is relatively less than the centralized databases. Next advantage is local control. These databases, I mean distributed databases, are controlled locally, so it is very easy to maintain them. So, disadvantages of distributed databases: it adds to complexity and cost. Since databases are distributed at multiple places, thus it increases the complexity and cost of the database. Next disadvantage is processing overheads. The distributed approach increases the overheads of the processing. Next disadvantage is data integrity. It is hard to maintain data integrity in this type of databases, as database is distributed at multiple locations and various operations performed on data at different locations lead to non-integrity of data. So, what are the differences between centralized and distributed databases? In centralized databases, all the data is present at single location. It allows for a greater control over accessing and updating data. This leads to the decreased overhead in updating the data, but it is also vulnerable to failure because they depend on the availability of the resources at the central site, whereas distributed database is stored on several computers, which ranges from personal computers to the mainframe computers. Computers communicate with one another through various communication media such as high speed networks or telephone lines. These are geographically separated and managed. These are separately administered. These have a slower interconnection. Now, we talk about the database categories on the basis of management. So, let us start with the hierarchical DBMS. Look at the figure. It shows the banking system. It shows the hierarchical representation of customer details and customer loan records from customer details and customer loan files respectively. Here note that loan with loan number 1011 is shown as taken jointly by Mike A. Smith and Graham S. Smith. Formally, the hierarchical data model organizes data in a tree structure. There is a hierarchy of parent and child data segments. This structure implies that a record can have repeating information generally in the child data segments. In the figure shown, root has 3 children labeled in orange color, and each child has further children shown in green color. Data is represented by a collection of records or record types. In the figure, the children of root shows that the record for each child storing the customer personal details, and further their children store the records storing the information about the customer loan unique identification number along with the loan amount. It is clear that the customer may have taken more than one loan from the bank, and both the loans are linked with that customer only. Thus, a record type is equivalent to the table in the relational model, and with the individual records being equivalent to rows. To create links between these record types, the hierarchical model uses parent-child relationship. In a hierarchical database, the parent-child relationship is one-to-many. In figure, you may observe that the customer has taken multiple records, and thus that customer details are linked with all those customer loan records, hence one-to-many. One customer record linked to many loan records. This restricts a child segment to have only one parent child. Hierarchical DBMS were popular from late 1960s with the introduction of IBM's information management system, that is IMS DBMS, through the 1970s. Now, let us explore network DBMS. Data in the network model is represented by a collection of records, and the relationships among data are represented by links or pointers. The records in the database are organized as collection of graphs. The network model permits the modeling of many-to-many relationships in data. In 1971, the Conference on Data Systems Languages formally defined the network model. Look at the figure. This figure shows the network model for bank. Assume that loan with loan number 1011 is taken jointly by two customers, Mike A. Smith and Graham S. Smith. In the hierarchical model, the loan information has to be repeated for every customer individually, because it does not permit many-to-many relationship. The parent-child relationship is one-to-many. However, in the network model, as it allows many-to-many relationship, the loan information is stored only once and both the customers can refer to it. In this figure, as the loan has been taken jointly by two customers, Mike A. Smith and Graham S. Smith, and for them the loan details are same. Thus, in network model, they can point to the loan details placed once and need not to be repeated for both the customers separately, as was in the case of hierarchical model. So, we come to relational DBMS. The relational model uses a collection of tables, also known as relations, each of which is assigned a unique name to represent both data and relationships among those data. A table has a specified number of columns, but can have any number of rows. Rows stored in a table resemble records from flat files. A row in a table represents a relationship among a set of values. Look at the figure. This shows two tables or relations. First relation has stored the details about the loans taken by the customers. Second table stored the personal detail of the customers. Both the tables are related to each other through the common column cust ID. Thus, the personal details are not repeated in the first table, because whenever the customer details are required, they can be fetched from the customer details table using the customer ID stored in the customer loan table. Now, let us explore the structure of the table shown here. The name of the table is customer details and customer loans. The vertical columns represent the column name or attribute name. or we can say field name. In the customer loan table, the columns are cust ID, loan number, amount in dollars, and the number of columns in a table is known as the degree of the relation or table, we can say. In this case, it is 3. Then the horizontal rows represents the records or rows or tuple that store the actual values corresponding to some transaction. For example, customer with cust ID 101 has taken a loan with loan number 1011 of amount 8755.00. So, 4 tuples are there in the table, thus the cardinality of the table is 4. So, in this lecture we have learnt about distributed databases, centralized databases, hierarchical data model, network data model, and finally relational data model. In the next lecture, we will discuss about the DBMS users, DBMS architecture, database languages like DCL, DML and DDL, etc.